Hello students, welcome to the interesting world of numbers and calculations. To begin with, I would like to draw your attention to some of the daily life situations. Mohan has some guests at home and he wants to prepare tea for them. They are 5 in number. Mohan knows to prepare tea for 2 persons. Now observe this table. These are the quantities of various items needed to make tea for 2 persons. 300 ml of water, 2 spoons of sugar, 1 spoon of tea leaves and 50 ml of milk. Can he take the same quantities of these items to prepare tea for 5 persons? Of course not. We know that as the number of persons increase, we have to take more quantity of all these items. That means, when one quantity increases, the other quantity also increases, or both the quantities increase or decrease together. Let us take another example. Kalam needs 2 kg rice to prepare biryani for 5 persons. What will be the quantity of rice that he need to prepare biryani for 15 persons? Even here, you can see that we have to take more quantity of rice as the number of people increases. That is, both the quantities increase or decrease together. Is this the case always? Let us check. Here is another situation for you. 2 students take 20 minutes to arrange chairs for an assembly. Then, how many minutes will 5 students take to arrange the same number of chairs in the assembly? Here, will they take more time or less? Yes, you are right. When we have more number of people to work, we need less time to complete the work. That is, when one quantity increases, the other quantity decreases. We come across many such situations in our day-to-day life, where in variation in one quantity bringing in variation in the other. Can we list some more examples? Look here. Number of articles purchased and the total cost. Money deposited in the bank and the interest earned. In both these cases, when one quantity increases or decreases, the other quantity also varies in the same way. Now, look at these examples. Speed of vehicle and the time taken to cover the same distance. Number of workers and the time taken to complete a particular work. In both these cases, when one quantity increases, the other quantity decreases. So, in all these examples, we have seen that a change or variation in one quantity leads to a change or variation in the other quantity. Now, here is a task for you. Do it yourself. Write 5 more such situations where a change in one quantity leads to change or variation in the other quantity. Now, let us see how we can actually calculate the quantity of items that we require. For example, in case of making tea or where we were arranging chairs for assembly. Let us see how can we find out the quantity which we do not know. To do this, we need to learn about some concepts of variation. The first one is direct proportion. So, today we are going to study about direct proportion. Consider these situations. Situation 1. Suppose Raghav's present age is 12 years and his father's age is 42 years. Then what will be their age 4 years ago, 6 years ago, 4 years later and 6 years later? Let us put it in a tabular form. In the table, you can see Raghav's present age is 12 years and his father's age is 42 years. Now, to answer the questions, let us see what we need to do. Raghav's age 4 years ago. To get this, we need to subtract 4 from his present age. That is 12 minus 4 is equal to 8. His father's age 4 years ago will be 42 minus 4, which is equal to 38 years. In the same way, we can find out their ages 6 years ago. Raghav's age was 6 years and his father's age was 36 years, which we obtained by subtracting 6 from their present age. Now, to find out their ages 4 years later, what should we do? Very good. We have to add 4 to their present age. So, we will get it as 12 plus 4, which is equal to 16 years, and 42 plus 4, which is equal to 46 years. Now, to find their ages 6 years later, very good, you have started calculating very fast. Raghav's age will be 12 plus 6, which is equal to 18 years, and his father's age would be 42 plus 6, which is equal to 48 years. Very good. Now, let us take another situation. Suppose a car uses 4 liters of petrol to travel a distance of 60 kilometers. Then, how long can it travel using 8 liters of petrol, 12 liters of petrol and 16 liters of petrol? Let us put this also in a tabular form to avoid confusions. It is given that by using 4 liters of petrol, the car travels 60 kilometers. Now, in the first question, we need to find out how long can it travel using 8 liters of petrol. That means, we are using double the amount of petrol. So, definitely the distance travelled also would double. So, the distance travelled would be 60 into 2, which is equal to 120. In the same way, we can find out the distance travelled by the car using 12 liters of petrol. 4 into 3 is equal to 12. So, we need to multiply 60 into 3, which is equal to 180. Last one, that is using 16 liters of petrol, how far will the car travel? 4 into 4 is equal to 16. So, we need to multiply the distance also with 4. That is 60 into 4 is equal to 240. Completed? Yes. Now, look at these two tables. What can you observe? We can observe that in both the cases, when one quantity increases, the other one also increases. But can you find some differences? Okay, let us observe more carefully and closely. In table 1, let us take Raghav's age as M and his father's age as N. Let us observe what happens to M by N. Good. Started calculating? Similarly, in table 2, let us take the petrol used as A and the distance travelled as B. Let us observe what happens to A by B. Let us start calculating. Yes, what a surprise! It's 1 by 15 throughout. Very good. Now, we can see that in the first situation, the ratio was not the same in all the cases, but in the second situation is a constant. You can even try the other way. Try to find out the values of B by A and N by M. We can see that the observations are the same. That is, the ratio is not the same in the first case and the ratio is the same in the second case. So, now we can say that the values A and B are in direct proportion. Now, can you tell me when we can say that two quantities are in direct proportion? Very good. You got it right. When the ratio of their corresponding values are equal. So, in general, two variables x and y are said to be in direct proportion if x by y is equal to k, where k is a constant, or x is equal to ky. As we have seen that the ratios 4 by 60, 8 by 120, 12 by 180 and 16 by 240 are equal in situation 2, where 60, 120, 180 and 240 are the distance travelled, that is the y value, corresponding to the amount of petrol, that is 4, 8, 12 and 16 liters respectively, which is the x value. We can say that when x and y are in direct proportion, x1 by y1 is equal to x2 by y2, where y1 and y2 are the values of y corresponding to the values x1 and x2 of x respectively. This can also be written as x1 is to y1 is equal to x2 is to y2. Hope you got the concept of direct proportion. Here is a task for you. Do it yourself. Check whether the examples that we have taken in the previous part are in direct proportion. List some more examples of direct proportion. Let us now try to solve some problems. Observe the following tables and find if x and y are directly proportional. What do you need to do here? Yes, to find whether x and y are in direct proportion, we need to find the ratio x by y. Okay. In the first column, 20 divided by 40, which is equal to 1 by 2. Next, 17 by 34, which is again equal to 1 by 2. 14 by 28, yes, which is equal to 1 by 2. 11 by 22 is equal to 1 by 2. 8 by 16 is equal to 1 by 2. 5 by 10 is equal to 1 by 2. And finally, 2 by 4 is also equal to 1 by 2. Good. What can we see here? The values of x by y is 1 by 2 in all the cases. That is, x by y is a constant. Therefore, we can say that x and y are in direct proportion. In the same way, try to find whether x and y are in direct proportion in the following examples also. Now, let us consider some more examples where we would use the concept of direct proportion. Here is an example for you. Example 1. The cost of 5 meters of a particular quality of cloth is rupees 210. Tabulate the cost of 2 meters, 4 meters, 10 meters and 13 meters of cloth of the same type. How can we solve this? Solution. Suppose the length of the cloth is x meters and its cost is rupees y. We can put it into the tabular form as given here. We know that as the length of the cloth increases, cost of the cloth also increases in the same ratio. So, it is a case of direct proportion. Here, we can make use of the relation x1 by y1 is equal to x2 by y2 to find out the unknown values of y. In the first case, x1 is equal to 5, y1 is equal to 210 and x2 is equal to 2. Therefore, substituting these values in our equation, we will get x1 by y1 is equal to x2 by y2, which gives 5 by 210 equal to 2 divided by y2. That is, 5 y2 is equal to 2 into 210 or y2 is equal to 2 into 210 divided by 5, which is equal to 84. Similarly, we can write as x1 by y1 is equal to x3 by y3, where x3 is equal to 4 and we need to find out y3. It is written as 5 divided by 210 is equal to 4 divided by y3. That is, 5 y3 is equal to 4 into 210 or y3 is equal to 4 into 210 divided by 5, which is equal to 168. Similarly, x1 by y1 is equal to x4 by y4 gives 5 divided by 210 is equal to 10 divided by y4. That is 5 y4 is equal to 10 into 210 or y4 is equal to 10 into 210 divided by 5, which is equal to 420. Finally, x1 by y1 is equal to x5 by y5 gives 5 divided by 210 is equal to 13 divided by y5. That is 5 y5 is equal to 13 into 210 or y5 is equal to 13 into 210 divided by 5, which is equal to 546. So, in this way we can calculate the value of y2, y3, y4 and y5, which corresponds to the cost of the cloth, which is measured 2 meters, 4 meters, 10 meters and 13 meters respectively. Hope you understood the calculations, and in the same way you can find answers for the questions that were posed in the beginning of the chapter. Example 2. An electric pole 14 meters high casts a shadow of 10 meters. Find the height of the tree that casts a shadow of 15 meters under similar conditions. Let us see how we can solve this. Solution. Let the height of the tree be x meters. Now, the length of the shadow can be taken as y meters. We can put it in the tabular form as given here. We know that as the length of the object increases, the length of the shadow also increases if the conditions are same. So, this is also a case of direct proportion. Let us try to solve this problem. Here x1 by y1 is equal to x2 by y2, where we take x1 as 14, x2 we have to find out, y1 as 10 and y2 as 15. Substituting these values, we will get 14 divided by 10 is equal to x divided by 15. By cross multiplication, we will get 10x is equal to 14 into 15. That is, x is equal to 14 into 15 divided by 10, which is equal to 21. So, the height of the tree is 21 meters. Dear students, I hope that now it is easy for you to do calculations based on direct proportion. Now, let us recall what all we have discussed today. We have studied about situations in which both the quantities increase or decrease together, or while one quantity increases, the other one decreases. We also learned that two variables x and y are said to be in direct proportion if x by y is equal to k, where k is a constant, or x is equal to k into y. Also, we have seen that if two variables x and y are in direct proportion and if y1 and y2 are the values of y corresponding to the values x1 and x2 of x, we can say that x1 by y1 is equal to x2 by y2, or it can be written as x1 is to y1 is equal to x2 is to y2. Also, we have learnt to determine whether the given two quantities are in direct proportion, and we have solved some simple problems based on direct proportion. Now, try to solve these problems on your own. Question number 1. The scale of a map is given as 1:3 crore. Two cities are 4 centimeter apart on the map. Find the actual distance between them. Question number 2. A machine in a soft drink factory fills 840 bottles in 6 hours. How many bottles will it fill in 5 hours? Hope you are clear about the concept of direct proportion. We shall meet in the next class to learn more about variations. Thank you children, and have a nice day.